Hello guys, this is a video solution to tutorial sheet number 2. So I will go through every single problem. There are 1, 2, 3, 4, 7 problems in this sheet. I will go through every one of them and write down the solutions. So this video solution is on top of the typed solutions which you can find on the course website. Okay. So let's start with question 1, which is this. You have this question. So you have a by-election. By polling a sample of voting population, we want to try to predict which of the parties will win. Now, which of the following methods of selections are most likely to yield a representative sample? So let's go through every one of them one at a time. Okay, let's start with the first one. This is question 1, part 1. Right? The first one says, poll all people of voting age attending a local football club. So the answer for this is not a representative. This is not a representative sample because not everybody likes football, right? Because not every voter likes football. Okay, that's question part 1. Part 2, poll all the people of voting age who are leaving an expensive town center restaurant on a particular evening. Again, this is not representative because not everybody can afford to go to an expensive restaurant, right? Right? Okay, that's part 2. Now part 3, let me take this up slightly. Okay, excuse me. Alright, let's down. Alright, here we are. Part 3 is obtain a copy of voter registration, randomly choose 500 names, and question each of them about their voting intentions. And this one, right, is this one is a representative. It's a representative sample, right? Okay, and part 4, it is a representative sample because you're choosing 500 names out of a registration list. So it's a voter registration list, so it's likely to be a representative sample. Part 4, use the results of a telephone poll in which a television asked its viewers to call and state their voting preference. Okay, this is unlikely to be a representative sample because not everybody has it or may have a telephone poll. May have a telephone. I mean, I know it's unlikely these days, but So there are people. I mean, there are people who do not have telephone, right? So it's unlikely to be a representative sample, right? So let me put this up. So let me write that down. So this is not because not every voter may have a telephone. Yeah. So that's part 4. Part 5 is to choose 200 names randomly from a telephone directory and call those people. So it's not a representative sample, because not everybody is likely to be in a telephone directory. Especially if you don't have a telephone, then you will not be on the telephone directory. So the answer is the same as part 4, that is. Alright, so let me write it down here. So for part 5, I mean, not a representative sample. Because not every voter may be in the directory. Alright, so this completes question 1 of tutorial sheet 2. Alright, now let's move to question number 2. I hope you can read this. Let me try to. This is question 2. It says, which of the following sampling schemes are likely to lead to representative sample? Alright, let's look at the first one. Right. So this is question 2, part 1. Yeah. To determine what the average person spends on a vacation, a market researcher interviews passengers aboard a luxury cruise liner, right? In this case, this is not a representative sample, because not a representative sample because most people who can afford a luxury liner are likely to be rich people, right? So it will not be representative of the entire population, right? Because only the rich can afford a luxury cruise line. All right, that's okay. Now part 2, determine the average income of its graduates 10 years after graduation. A university sends questionnaires in 2015 to all members of the class of 2005 and bases its estimates on the questionnaires returned. Alright, here it's again not a representative sample because when you send questionnaires to people, they may not actually record what their true salaries are. For example, if somebody is earning, say, over 100,000, they may be reluctant to record that because other people may find out that he's earning so much. Okay, so people are not likely to record their true salaries, right? So it's again not a representative. Because because graduates are not likely to report their true incomes. I mean, if somebody is earning like less than, say, 10,000 or 15,000, again they may feel ashamed to report their income because it's so little compared to others. Okay, so all right. Now part 3. Let me take this up. To determine public sentiment about certain import restrictions from a particular country, an interviewer asks voters, do you feel that this unfair practice should be stopped? Again, the way the wording is, if you look at the question, it says unfair practice should be stopped. So the way it is worded, right, it makes you think that even if people think that it shouldn't be stopped, they would say it should be stopped. All right, so the data that comes from this question is likely to be not representative, right? So the answer is this, not a representative sample, because of the wording of the question. All right. I mean, the question is worded in such a way that even if people think it is a fair decision, they may say it is unfair, right? Okay, so it's not likely to yield a representative sample, right? So these are the answers to question number 2 of tutorial sheet 2. So let's go to the next question, which is question 3. It's this one. Sorry, it's this one, guys. Hopefully you can see it. All right. Here, a population consists of these numbers 2, 3, 6, 8, and 11. And let x1, x2 denote the first and second numbers in a sample of size 2 chosen with replacement. Right? With replacement. Calculate the population mean. That's part 1. Right, so let's try to do this. So this is question 3. You have, oh, sorry, I can't see it. Okay, here we are. Question 3. You have a population. So the population is is made up of these numbers 2, 3, 6, 8 and 11. Okay, and the question is to find the population mean, right? Now the population mean is simply the expected value, right? So because you're doing it with replacement, right? The possible outcomes, right, can be for the first number that you choose can be either 2, 3, 6, 8 or 11, and the probabilities since there are 5 numbers in total, the probability of choosing 2 is 1 over 5, 3 1 over 5, 6 1 over 5. All right, so the population mean, all right, which is basically the expectation of x1, right? This is going to be 2 times 1 over 5 plus 3 times 1 over 5 up to 11 times 1 over 5. Okay? Alright guys, so you should compute this. You will get this to be equal to 6. Right? Alright, so that's the population mean. Right? So that answers the first part. The second part of the question is to find the variance of x1, right? So we want to find the variance of. So remember the variance of x1, which is the population variance, right, can be written as, I'm sure you did this in probability 1, which you took last semester. Can be written as this. Now this guy here, we already know what it is. So this is the expectation of minus the square of 6, which is 36. So what we need to find, guys, is we need to find the expectation of x1 squared, right? So that's what I'm going to do. x1 squared is going to be 2 squared times 1 over 5 plus 3 squared times 1 over 5 okay. Now if you compute this, guys, you will get the following: 2, 3, 4 divided by 5. This is what you will get. Hence the variance of x1 is 234 divided by 5 minus 36, and this is equal to 10.8 approximately. Okay. Alright guys, so that's part 2 of question 3. Right, now let's move on to part 3. This is question 3, part 3. Right, the question is by considering all samples for x1 and x2, calculate the mean and the variance of x bar. X bar is the average of x1 and x2. Right? So the first thing you need to do is to write down all possible outcomes for x1 and x2. So that's what I'm going to do here. So start with the first possible outcome is 2, 2. 1, 2, 3, 2,6 to 8 to 11, then 3, 2, 3, 3, 3, 6, 3, 8, 3, 11, then 6, 2, 6, 3, 6, 6, 6, 8, 6, 11. Right, and next 8, 8, 2, 8, 3, 8, 6, 8, 8, 8, 11. Right, and next 11, 2, 11, 3, 11, 6, 11, 8, and 11, 11. So these are the possible outcomes of X1 and X2. Now for each of these, there is a corresponding X bar, right? So what I'm going to do here is write down the values of X bar corresponding to each of these outcomes. So for 2, 2, it will be 2, right? For 2, 3, it is 2.5. For 2, 6 is 4. 2, 8 is 5. 2, 11 is 6.5. 3, 2 is 2.5. 3, 3 is 3. 3, 6 is 4.5. 3, 8 is 5.5. 3, 11 is 7. 6, 2 is 4. 6, 3 is 4.5. 6, 6 is 6. 6, 8 is 7. 6, 11 is 8.5. 8, 2 is, the average is 5. 8, 3, the average is 5.5. 8, 6, the average is 7. 8, 8, the average is 8. 8, 11, the average is 9.5. And 11, 2, the average is 6.5. 11, 3, 7. 11, 6, 8.5. 11, 8, the average is 9.5. And 11, 8, the average is 11. Right. So these are the possible values for X bar that you can get. Right. So now from this table, you should be able to construct a probability distribution for X bar. Right. And I'll show you how to do that in a sec. Right. So, all right, let me keep this table here. Now from this table, you have possible values for X bar, right? And you have the corresponding probabilities. Now the possible values for X bar, the ones you've seen in the previous table, are these. It's 2, 2.5, 3, 4, 4.5, 5, 5.5, 6, 6.5, 7, 8, 8.5, 9.5, and 11. So these are the possible values for X bar. Now, to find the corresponding probabilities, what you need to do is you go back to this table right? Go back and see like how many times you have you had 2. So if you look at this table, how many times you had 2, there's only one out of the 25 outcomes have 2 in it. So the probability corresponding to this is 1 divided by 25 is the total number of outcomes in this table, right? Now for 2.5, how many of these outcomes have 2.5? There is 1 here and there's 1 here. So there are 2 outcomes corresponding to 2.5. So the corresponding probability is 2 out of 25. All right? And similarly, the next one, for 3, how many of these outcomes have 3 in it? There's only 1. There's only 1 with 3 in it. So the probability is 1 divided by 25. The next one is 4. There's 1 4 here, and there's 1 4 here. So there are 2 outcomes with 4 in it. So the probability will be 2 over 25. And you keep doing that, all right? So for the next one, 4.5, there are 2 outcomes out of 25. For the next one, there are again 2 outcomes out of 25. 5.5, you have 2 outcomes. 6, you have 1 outcome. 6.5, you have 2. 7, you have 4 outcomes. 4 outcomes out of 25. 8, you have 1 outcome. 8.5, you have 2 outcomes. 9.5, you have 2 outcomes. And finally 11, you have 1 outcome. So this table here constitutes the probability distribution for X bar being the average of X1 and X2. Now, to answer the question, if you go back to question 3, part 3, the question was to find the mean and the variance of X bar. Right? All right, so let's start doing that. So to find the mean, which is the expectation of X bar, right? You just use the standard formula. You multiply this column with this column and add them up. So it will be 2 times 1 over 25 plus 2.5 times 2 over 25, and so on until the very last term will be 11 times 1 over 25. Alright, so if you calculate this will be equal to 6. Right? Now, in order to find the variance, you use the familiar formula, which is this is the formula. Right? I'm sure all of you know this. Alright, so this will be the expectation of, this is 6, so this will be 36. Right? Okay. Now to compute this guy here, you use the familiar formula, which is 2 squared times 1 over 25 plus 2.5 squared times 2 over 25 up to 11 squared times 1 over 25 minus 36, right? Now if you do the calculations, this will come to around 5.4 approximately. Alright, so this completes part 3 of question 3, alright, and also completes the solutions to question 3. Alright, the next question, let me show you here, is this one, question 4. So it's an extension of question 3, The question is to repeat basically what is in part 3 of question 3, but when the sampling is without replacement. So here we did it with replacement, but here we're going to do it without replacement. Okay, so all right, let's see how we can do it. Okay. Now, the first thing you need to do, as I said before, the first thing you need to do is to write down the outcomes, right? Is to write down the outcomes of that you can have, right? So the outcomes and the possible values for X bar. There are going to be 2 columns, right? Because we are doing it without replacement, there will be fewer outcomes. So you can have 2, 3, 2, 6, 2, 8, 2, 11, 3, 6, 3, 8, 3, 11, 6, 8, 6, 11, and 8, 11. Now you may note that I have chosen 2, 3, but not 3, 2. And similarly, I have chosen 2, 6, but not 6, 2. The reason for that is because you can actually have it. You can have 2, 3, and 3, 2, and 6, 2, 2, 6, and 6, 2, but the results will be the same. It will not make any difference to the final answer that we're going to get. All right. So here, in this case, the order doesn't matter. The order that you choose the numbers doesn't matter. Whether you choose 2 first and then 3, it's the same as choosing 3 first and then 2, right? So that's why I have chosen this, right? Done it like this, right? Okay, now let's compute the values of X bar, right? So these are the outcomes for X1, X2, right? Now X bar is the average of X1 and X2. So for 2, 3 it will be 2.5, right? For 2, 6 is 4. 2, 8 it will be 5. 2, 11 is 6.5. 3, 6 4.5. 3, 8 5.5, 3, 11, 7, 6, 8. Now it's 7, 6, 11. It's going to be 17 divided by 2, which is 8.5, and 8, 11, which is 19 divided by 2, which is 9.5. So these are the possible outcomes and the corresponding values for X bar, right? Now we can write down. Now, okay, this is one table we have done with. Right, the next table, right, is I'm going to write down the values for X bar and the corresponding probabilities, right? Okay, all right, and as you okay, the different possible values for X bar are these: 2.5, 4, 4.5, 5, 5.5, 6.5, 7, 8.5, and 9.5. Okay, these are the possible values for X bar. Now let's do the probabilities. There are, as you can see, there are 10 possible outcomes here. There are 10 of them. So 2.5 only occurs once. So the probability is 1 divided by 10. 4 occurs again once. 4.5 occurs once. 5 occurs once. 5.5 occurs once. And 6.5 occurs once. And 7, you should look at 7. There are 2 outcomes with 7. This is 7, this is also 7. So that's 2 outcomes out of 10. 8.5 occurs once, and 9.5 occurs once. Alright, so this is the probability distribution of X bar when you draw without replacement. Right, now the next thing we need to do is we need to compute the mean and the variance, which is done the same way as in question 3, right? So let's do that. So to compute the mean, right? You just say what you do is just you simply multiply this column with this column and then sum them up, right? So you will get 2.5 multiplied by 1 over 10 plus 4 Alright, so this is the mean, right, or the expectation, and if you calculate this will be equal to 6. Okay, and to find the variance, use this formula. So this is going to be the expectation of minus 6 squared, which is 36. Okay, to find this, you use the same thing. So you square the numbers in the table and multiply with the probabilities. Alright. Now you should do this math, you should do the math for this, you will get 4.05. Okay, this is what you get, right? So now you should compare the value of mean and the value of variance with the corresponding values you got in question 3. The mean is the same, right? But the variance is slightly smaller, because you should go back to the solution for question 3, part 3. You will see that the variance, when you did with replacement, it was 5.4, right? Now what we get here is 4.05, which is smaller. So the question, so what you can write is the following: the means are the same. Alright, the mean, that is the expectation of X bar is the same with replacement and without replacement. But the variance is smaller. Right, the variance is smaller for without replacement. Okay. Alright, so that completes question 4 of tutorial sheet 2. Right, now let's move to the next question 5, right? Is this one? Let me try to zoom in. Okay, here we are. So this time you have a population that consists of the numbers 3, 7, 9, 11 and 15, right? They are symmetrically distributed around the volume 9. Okay, the first part is to calculate the population mean, right? So let's see how we can do that. So that shouldn't be difficult. So you just, so this is question 5. You have the number, the population. The population consists of the numbers 3, 7, 9, 11 and 15. Okay. To compute the population mean, which is the same as the expectation, right? Because each of these has equal probabilities, there are 5 numbers, right? There are the probability of choosing any one of them is 1 over 5. So it's going to be 3 times 1 over 5 plus 7 times 1 over 5 and so on until 15 times 1 over 5. Right, so if you compute this, you will get the population mean to be equal to 9. Okay. All right. All right. Part two of the question is, let me zoom in. All right. Part 2 is to write down all possible samples of size 3, which can be drawn without replacement, right? And hence calculate the mean and the variance of X bar, right? Okay. Okay. Now this time is a little bit more involved, right? Again, because we are doing it without replacement, the order here really doesn't matter. The order that you choose, whether you choose 2 first and 3 second, is the same as the other way around, right? Okay. So the first thing you need to do. The first thing you need to do, guys, is to write down the outcomes and the values for X bar, right? So that's what I'm going to do. So this is part 2 of question 2, right? So I'm going to create a table with two columns. So the first column are the outcomes, right? And the second column is the values for X bar. X bar is the average of you are choosing 3 numbers, X1, X2, X3. Right? Okay, so the outcomes are as follows: 3, 7, 9. Alright, so these are the possible outcomes. So once again, the order of the numbers it doesn't matter, because even if you change, I mean, even if you take account of different orders, you will still, the answer, the final answer that we're going to get, it will be the same, right? So for example, you should add like 379 and 397 and 739 and all the other possible orders for each of these, you will get the same answer, right? Okay. All right. Now for each of these outcomes, there's a corresponding x bar. X bar is the average of these numbers, right? So it's going to be 19 divided by 3, 21 divided by 3, 25 divided by 3, and 23 divided by 3, 27 by 3, 29 divided by 3, 27 divided by 3, 31 divided by 3, and 33 divided by 3, and 35 divided by 3. All right, so this is the table corresponding to x bar, right? Okay. Now, if you look at you can construct now a table with the different possible values for x bar. So let me down here I'm gonna create a new table with the value. It has two columns. The first column lists the possible value, the distinct possible values for x bar, and the second column gives you the probabilities. All right. Now, if you look at okay, 19 over 3, 21 over 3, then you have 23 over 3, then you have 25 over 3, you have 27 divided by 3, right? And then you have 29 divided by 3, you have 31 divided by 3, okay? And then you have 33 divided by 3, and finally you have 35 divided by 3. So these are the distinct possible values for x bar. Now for each of these there's a corresponding probability. 19 over 3 occurs only once, 1 out of 10. You see there are 10 possible outcomes here, right? 21 over 3, how many times? You have only one, so it's 23 over 3. 23 over 3, you have only one time, right? Correct me if I'm wrong. 25 over 3, you have one time. 27 over 3, 27 you have 2 times, 1, 2, 27, yeah, you have 2 times. 29 you have 1 time. 31 you have 1 time. 33 you have 1 time. 35 you have 1 time. So I hope I'm correct. So let me count 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So this is correct. All right. So this is the probability distribution for x bar for question number 5. All right. Now we need to compute the mean and the variance. I'm sure you know how to do it, right? So let's see how we can do that. So to find the mean of x bar, so you just simply multiply these two columns, right? That is this column with this column, and then sum them up, right? So it's gonna be okay. Now you should sum this. You will get the answer will be 9. Okay. All right. Now to find the variance, you use this familiar formula, which is the expectation of the square of this minus the square of this. So it's gonna be the square of 9 is 81. All right. All right. So now to compute this guy here, you square the square of the first column and multiply with the second column. Right. So it's gonna be what you do, and then you subtract 81. Now if you do the calculations, right, you will get approximately equal to 2.667. All right, so this is the mean of x bar, and this is the variance of x bar, of the sampling distribution of x bar. Right? Right, so that completes part 2 of question 5. We are still in question 5, so let's go back to question 5. So this is where we are. All right, so we've done part 1 and 2. Part 3. Now use your list of possible samples to calculate the mean and variance of the sampling distribution of the sample median. Right. Okay, so instead of sample mean, we're going to calculate the sample median. Okay. All right. So that means we need to go back to the table here. We need to go back to this table here. I mean, and instead of x bar, we need to compute the sample median. Right. So let me redraw the table. Right. Okay. Let me. All right, I think it's best to start on a new page. All right, let's start on a new page, guys. So I don't want to confuse you guys. So this is part 3 of question 5. All right, so I'm going to start a new table here. The first column are the outcomes. And the second column is the, let me call it median. Remember, median is the middle value when you order the data. Right? So outcomes are the same as before, which is 3, 7, 9. Alright, so these are the possible outcomes. Alright, now let's compute the corresponding median. Now, the median is the middle number when these are obviously ordered from the smallest to the largest. So the median is easy to pick what the median is. So this is, the median is 7 here. The median here is also 7. The median here is also 7. For here, the middle number is 9. The middle number is 9. 11. The middle number here is 9. And the middle number here is 11. The middle number here is also 11. Right? Okay, guys, so that's the first table. The second table that we need to draw are the possible values for median and the corresponding probabilities. Now the possible values are clearly 7, 9, right, and 11, right? Okay. Now how many 7s you have? You have 1, 2, 3. So it's 3 out of 10. How many 9s we have? We have 4 out of 10. How many 11s? We have 3. Alright, so these are so this table here gives the probability distribution of the median. Alright, now to compute we need to compute the expectation and the variance, right? So let's first start with the expectation. So to find the expectation, you should simply multiply this with this column and sum. So it will be 7 times 3 over 10 plus 9 times 4 over 10 plus 11 times 3 over 10. Okay. So if you do the calculations, you will get this to be equal to 9. Okay. Now to find the variance, of median, use this formula. You know this is 9, so this will be the expectation of $81. Alright. Now to find this, you just simply say 7 squared times 3 over 10 plus 9 squared times 4 over 10 plus 11 squared times 3 over 10. Alright? Now if you do the math for this, right, you will get 2.4. So the answer for the variance is 2.4. Okay? Alright, so now that's part 3 of question 5. Now part 4 is asking you to compare the results of parts 2 and 3. Right. You may recall that in part 2 the variance was 2.667 and in part 3 the variance is 2.4. So you can see that the variance for the median is smaller. So you can say that so this is part 4. The means are the same. The means are the same. I mean, the mean was 9. The expectation of X bar was 9, if I remember correctly, and the expectation of the median is also 9. But the variance for the median is 2.4, which is smaller than what we got for the variance, excuse me, is smaller than what we got for the variance of X bar. So you can say the variance is smaller for the sample median. Okay, it's smaller for the sample median, right? Okay, so this completes question 5 of tutorial sheet 2, right? So let's go to the next one, which is question 6. Question 6 is this one. Sorry, excuse me. So you have a sample of size 10 from a uniform distribution on the interval 0 to 1. Calculate the mean and the variance of the sampling distribution of X bar. Right? All right. So it's not really difficult. This is question 6. You have x1 to xn, so x1 to xn is a random sample from a uniform distribution on the interval 0 to 1. Right, and the question is to find the mean and the variance of X bar. Right? Okay, let's start with the mean, right, of X bar, which is the expectation of X bar, which is right. So you can take the expectation inside, so it will become okay. Now to find the expectation of xi, we know that each of these guys is uniformly distributed from 0 to 1. Okay, so it's going to be the integral from 0 to 1 of x times the PDF is 1 also, right? The PDF of this is 1 dx, right? So this is going to be 1 over 10 x squared by 2. Okay. So this is going to be 1 over 10 times the sum. The limit at 1 is half, the limit at 0 is 0. Okay, so this is going to be half, so it's 1 over 10. This, because this being a constant, the sum of a constant is simply 10 times the constant, right? So the answer is half. Alright, so this is the mean of X bar, right? Now to find the variance of X bar, let me start on a new page, right? Just to find the variance of X bar. This is same as let me write it like this, the same as the variance of 1 over n times the sum of, sorry, 1 over n being 10 here, n is the sample size, which is 10, right? And if you take the 10 outside, right, and bring the variance inside, you will get 1 over 100 Okay. All right. You are allowed to do this because xi is a random sample. That means they are independent and identically distributed. So you can bring, they are independent, so you can bring the variance inside the sum. Right? This is what you have, right? Now each of these is easy to work out. Right, to find this, you just integrate 0 to 1 of x squared times 1 times dx, right? To find this guy, you do the same thing. Yeah. Okay. Alright, the integral of this is x cubed by 3, limits 0 to 1. The integral of this is x squared by 2. Take the limits 0 to 1. Right? Then you need to square this, right? Okay. Okay, guys. Right now, taking the limits, we get 1/3. Yeah, and here you get 1/2 squared. Okay. So this is going to be 1/3 minus 1/4. Right? So it's going to be 1/12. Yeah, this is a constant, right? So it's going to be 1/100 times 10 times the constant, right? So the answer is 1 divided by 120. So this is the variance of x bar, right? Okay. So this completes question 6 of tutorial sheet 2. The next question, the final one, is question 7. There we go. So here you have a Poisson distribution with parameter lambda, and the value of lambda is unknown, but it's known to be either equal to 10 or 12. And you have a random sample from a population, which is this. Calculate the joint probability and which value of lambda results in the given sample being most likely to occur. Alright, so let's see how we can do that. So this is question 7. Okay. So we want to, we have 6 data points here. Was it 5 was 5? 1, 2, 3, 6. It should be 6. 1, 2, 3, 4, 5. There is 6 missing here. there should be 6 data points, okay? Okay, there should be 6 data points here. So we want to find the joint probability that the capital okay, we want to find this probability, and we know that x1 to x6 is a random sample, right? Which means they are independent, right? So because they are independent, we can write them like the product. Because these variables are independent, you can write this as a product 1 to 6 of the probability that capital Xi equal to little xi, right? Now we know that we are assuming that this is a Poisson random variable. So that means E of, you know the probability mass function for Poisson, which is E of minus lambda power xi divided by xi factorial. Okay. Now you take the product of this from 1 to 6, so you get E of minus 6 lambda, yeah, lambda power sum of xi 1 to 6, and then you divide by the product 1 to 6 of xi factorial. Yeah. Okay, guys. Now, for the given values for x, you are given in the question. You are told that x1 to x6 are equal to these numbers here, right? So you should sum them. If you sum them up, right, this can be the sum of xi. The sum of the given values of xi is 59. So this is lambda power 59, right? Sorry, 559 divided by the product of xi factorial, which are 9 factorial, 13 factorial, 6 factorial, 8 factorial, 10 factorial, 13 factorial. Alright, so this is the joint probability for the given random sample. Right? Now the question is asking you, is saying that the possible values for lambda can be either 10 or 12. And then it's asking which of these values for lambda will result the sample being more likely. So what you need to do is basically, let me call this star, right, just for sake of notation, right? Okay, now, as you can see, the only thing that is unknown about this is lambda. So if we know that lambda can be either 10 or 12, so if lambda is equal to 10, then you can put in lambda equal to 10 into this formula and compute it, right? And you will get it to be approximately equal to, and if you do the math, then you will get the following. This is what you will get. If you put lambda equal to 10 into this and work it out, this is what you get. And if you put lambda equal to 12 and work it out, you will get it to be equal to 1.704 times 10 to the power minus 7. So the joint probability is this when lambda is 10, and this when lambda is 12. Clearly, this one is bigger than this, right? So the answer is lambda equal to 10 is more likely. Is more likely to occur, right? Alright, so this completes the solutions to question 7 and also completes the solutions to tutorial sheet 2.